Hey everyone, welcome to This Explainer. I am so glad you're here today because we're unpacking the absolute invisible magic that powers literally every second of your digital life. So think about this for a second. What actually happens when you hit enter? You type in a website, press a key to stream a video, and boom, the page just appears out of thin air. It feels completely instantaneous, right? But behind the scenes, you're kicking off this highly choreographed journey that relies on some incredibly strict architectural rules. Okay, let's dive into this. Modern networking is basically this invisible architecture that perfectly connects devices all over the globe. The sheer volume of data moving around the Earth right now is staggering, but the internet manages it with breathtaking precision. And it does this using three core protocols: IP, DNS, and HTTP or HTTPS. These are the load-bearing pillars of everything we do online. And here is our blueprint for today. First, we'll look at the magic of networking, then break down our three load-bearing pillars: IP, the addressing system; DNS, the internet's phone book; and HTTP/HTTPS, secure delivery. Finally, we'll see all these pillars in action together. Section 1. The magic of networking. Let's get right into it. Seriously, it is mind-blowing that everything we're about to talk about happens in just milliseconds. It's a high-speed journey triggered by a single click. In fact, right now, as you are streaming this very explainer, this high-speed process is actively working for you. Your device is constantly routing data packets and reassembling them perfectly so you get a smooth, uninterrupted presentation. But for that to happen, your device needs to know exactly where to look. Which brings us to Section 2, IP, the addressing system. Let's talk about digital real estate. Think of this like the ultimate global post office. Every single device out there, your phone, your smart TV, the actual server hosting this explainer, they all require a unique digital street address to send or receive a digital letter. Just like a physical piece of mail in the real world, your data needs an exact street address to arrive safely. Now, what's really interesting about this slide is that this abstract string of numbers separated by periods is what an actual internet protocol address physically looks like. To a router, a number like 192.168.1.1 is perfectly logical. It's an exact coordinate on the digital map. But let's be real, we humans are absolutely terrible at remembering long numerical strings. I mean, imagine trying to memorize 50 different 10-digit numbers just to check your email, read the news, and stream a video. No way. And that leads perfectly into Section 3, DNS, the Internet's phone book. Here is the core problem. Humans speak in names, but computers speak in numbers. We just want to type in easy-to-remember words, but the computers doing the heavy lifting absolutely require those IP numbers. So, the domain name system, or DNS, steps in as the ultimate translation layer between human memory and computer logic. And fun fact, the global DNS system handles trillions of these translation requests every single day without even breaking a sweat. And this brilliantly illustrates how those microseconds actually play out. Step 1, you type a URL. Step 2, your browser quickly checks its local cache to see if it already knows the address. If it comes up empty, Step 3, it asks a digital switchboard called a DNS resolver to check the global phone book. Finally, Step 4, the resolver returns the exact IP address and the connection is made. All of that happens before you can even blink. All right, moving on to Section 4, HTTP and HTTPS, the secure delivery. Let's talk about how this data is packaged up and protected. So the crucial point is why that S in HTTPS matters so much. HTTP gets the job done, sure, but it's basically like sending a postcard through the mail. Anyone who intercepts it can just flip it over and read the back. HTTPS, though, adds this crucial layer of encryption. It's literally like putting your data inside a locked safe, inside an armored guard truck. That S is the absolute bedrock of your digital privacy, keeping all your passwords and personal data safe from prying eyes. So here are the rapid-fire delivery rules. It establishes the network communication. It packages the data super efficiently into lightweight packets optimized for fiber optic speeds. And it protects it all from prying eyes with HTTPS. Boom, boom, boom. Package it, encrypt it, route it, all in a fraction of a second. Which brings us to our final part, Section 5, the pillars in action. Let's move to and see how this builds together into one cohesive system. IP handles the precise origin and destination, that's your street address. DNS seamlessly translates our human words into computer numbers, that's the phone book. And HTTP or HTTPS ensures the secure data delivery, our armored truck. Without even one of these structural pillars, the modern web literally just collapses. But together, they work in perfect, silent harmony. So, I want to leave you with this one provocative thought. Just in the time it took to read this slide, how many billions of digital envelopes do you think just safely found their home across the globe? The sheer scale of it is just wild, yet this invisible architecture holds strong every single day. Keep questioning the tech you use, and I will see you in our next explainer.